Okay, hi everyone. So in this video, we will be looking at the 2012 A-Level H2 Math Paper 1, Question 8 on differentiation and its applications. So in this question, we are given the equation of the curve. The curve has only one turning point, and we are supposed to show that 1 plus dy dx equals to 2 over 2x plus 2y plus 1, 4 marks. Okay, so we start off with the equation of the curve, which is x minus y equals to x plus y squared. If you want to find the first derivative, dy dx, you have to differentiate both sides of the equation with respect to x. So you will get 1 minus dy dx, differentiating y with respect to x. And then for the expression on the right-hand side, power bring down, power minus 1, and then you differentiate the expression inside the bracket. This will give you 2 x plus y, 1 plus dy dx. Okay, so when I differentiate x, I get 1. When I differentiate y, I get dy dx. Okay. After we are done with that, we can open this up because we have to prove the following equation. So we have 2x plus 2y, 1 plus dy dx. So we open up the first bracket. And then, after that, multiply the 2x plus 2y into 1 plus dy dx. So this will give us 2x plus 2y times 1, 2x plus 2y times dy dx. Okay. And then after that, we are supposed to prove that 1 plus dy dx equals to 2 over 2x plus 2y plus 1. So we bring all the terms with dy dx onto one side. So that will give us, okay, so let's say we bring this over to the right-hand side. Okay, so we have 2x plus 2y dy dx plus dy dx. Okay. And then for the 2x plus 2y over here, we will bring it over to the left-hand side. So we have 1 minus 2x minus 2y. After that, we will make dy dx the subject. So I'm factorizing the dy dx out. This will give us 1 minus 2x minus 2y. Okay. Divide 2x plus 2y plus 1 over. I have 1 minus 2x minus 2y over 2x plus 2y plus 1. Okay, then some of you will get stuck here. How am I supposed to prove this? Now in the exam, how we proceed with our working depends on what we are supposed to prove. So in this case, I have the dy dx already. The only term that I am missing is the 1 over here. So what I will do from here is I will add 1 to both sides of the equation. Okay, so I repeat, I am adding 1 onto both sides of the equation so that the left-hand side is what we want to prove. And then for the right-hand side, you will be able to see that a lot of the terms actually cancels out. So you are left with 2 over 2x plus 2y plus 1. Okay, equals to right-hand side. Sure. Okay. So all these terms, they actually cancels out each other. This is how we prove part 1. Pretty long. That's why they give us 4 marks for this. So you guys can pause the video to take the working down and to see what's going on, because I will be erasing the steps so that I got space to do my part 2. Okay, moving on to part 2. Hence or otherwise show that the d2y dx squared equals to negative 1 plus dy dx, the whole thing cubed. So what we will do is we will differentiate the equation we have in part 1 again to get the second derivative. So if you differentiate 1, you will get 0. You differentiate dy dx, you get d2y dx squared. And then you need to differentiate what is on the right hand side. I mean, for those of you who wants to do quotient rule on the right hand side, you can go ahead. But an easier way to do this will be to shift the denominator to the numerator and account for it with a negative index so that you use chain rule instead of quotient rule. The working will be a lot neater. So power bring down, power minus 1, and then you differentiate what is inside the bracket. When you differentiate high power, okay, make sure you differentiate the expression inside the bracket. So this will give us negative 2 over 2x plus 2y plus 1, the whole thing squared. Okay, so I'm basically rewriting this in this manner, all right? Then after that, I will have to differentiate 2x plus 2y plus 1. This will give me 2 plus 2 dy dx. When you differentiate 1, it becomes 0. So simplify, all right? And again, like I said, how we simplify or arrange the terms depends on what we are supposed to prove. So in this case, I'm supposed to have 1 plus dy dx cubed on the right hand side. So I'm going to factorize out 2 from the second term so that I have 1 plus dy dx out, one of them. So out of the 3, I have one of them out already. So now based on the equation that we are supposed to prove, our next job is to find out how come the term that I have highlighted is 1 plus dy dx squared. All right. So from part 1, if you guys go back to the working in part 1, we have 1 plus dy dx equals to 2 over 2x plus 2y plus 1. Now, if you square both sides, you see that 1 plus dy dx squared is actually 4 over 2x plus 2y plus 1 squared, which is what I have highlighted over here. All right. So simplifying d2y dx squared is actually negative 1 plus dy dx squared 1 plus dy dx. So if I put everything together, I will get 1 plus dy dx cubed, which is what we are supposed to show. All right, this is for part 2. So same thing, you might want to pause the video for a while for you to take down the working because I'm going to erase them. Okay, let's go on to part 3. Hence, state with a reason whether the turning point is a maximum or minimum point. Now, at turning point, okay, TP stands for turning point, yeah? Our dy dx equals to 0. And then, our d2y dx squared, as proven in part 2, is given as negative 1 plus dy dx whole thing cubed. But as we know, at the turning point, the first derivative, dy dx equals to 0. So replace dy dx with 0. You get negative 1 cubed, which is negative 1, lesser than 0. Therefore, the turning point is a maximum point. All right, so this is something that you don't see quite often. It is an unconventional way to find the nature of the turning point. All right, so there you have it. This is how we solve question 8. So I see you guys in the next video on question 9, which is on the chapter vectors. All right, so see you guys.